design for the reinforced concrete, we have different standards, codes, and specifications. And in your design projects, particularly when you go to a higher design subject, when you go to your design project, this might be of help to you in your undertaking in all the uh, design subjects that we are design projects that you might be undertaking in the future. So there are several standards, codes, and specifications which we can use in the design for reinforced concrete. One of which is the ACI code. So the ACI code is also the basis for the National Structural Code of the Philippines, and one of that, the codes, one of the parts of the code is the design for the beam, which we already have discussed. I have given you one problem, one example problem for the design for the beam. So these are some contents of the ACI code, the American Concrete Institute, and there are several commentaries here with regards to AISC, or the American Institute of Steel Construction 360, simply because beams are designed for provisions of reinforcement. So we have different notes here. So this is the difference between the NSCP and the ACI code. So the ACI code is a general standards, codes, and specifications. While the NSCP are those are adapting the NSCP has adopted the ACI code. So just to give you idea of the National Structural Code of the Philippines. So this is how you're going to choose for the loadings. Okay, so there are several classifications of structures. You have the different occupancy category, and then of course you have the different load combinations. So this is the 2015 edition, and in the 2015 editions, you are given the different load combinations. So the basic load combinations that you have here is the strength design load and the resistance factor design are used. The structures in all portions thereof shall resist the most critical effects. When you say most critical effects, the largest one. So you're going to choose whichever load combination might be applicable, and then you choose among the load combination is the most critical one. Okay? And then you have here some alternate basic load combinations. So when you design a project, particularly a building or a vertical structure, you're going to make use of this load combination, load combinations and basic load combinations, and also these procedures for the seismic load. I mean, load combinations using the seismic provisions. So again, just as the design for structural steel, we are using also the LRFD here and the allowable strength design. Formerly, they are called ultimate strength design and working stress design method. So now they are called load and resistance factor design method and the allowable strength design method for the steel. So there are seismic load combinations here. If you are going to consider the earthquake seismic provisions, then you have to make use of this load combination. So these are the minimum design loads, the weight of the materials, and the construction. So just to give you an idea, brief idea of the design loads for the materials that you're going to use, these are all identified here in the ACI code, as well as the National Structural Code of the Philippines. Okay. So in the design for reinforced concrete, ito kasi yung duma natin. This is the old combination, load combination for the working stress, for the concept of the design. One of the concept of the design is in the reinforced concrete is the AC in the reinforced concrete is what you call as USD, or the working stress design method. So dalawa yung klase ng method na ginagamit natin. The particularly being used for today is the ultimate strength design method. Okay. So because of some drawbacks in the working stress design method, they made use or popularly used now is the ultimate strength design method, because the working stress design method as not consider the differences between the dead loads and the live loads. So that is one of the drawbacks of the WSD. Okay, so they do not consider in the WSD, they do not consider the difference between the dead loads and the live loads. Okay. Another drawback of the working stress design method is that it is inaccurately assuming that the concrete will behave in a linear fashion with an increasing stress level. So merely knowing the stress level will not assure or ensure us that there is a correct prediction of the undesirable level of stress. Okay? And another drawback of the WSD is that the most significant drawback, there is a condition that it is unimportant to know the stress level in the structure. So what is important in WSD is to know how much overload the structure can take before it will fail. So unlike for the ultimate strength design method, wherein strength is considered, and the strength is needed to have a safe design, adequate strength, so that the structure will not fail, whether the actually occurring loads will be underestimated or excessive. So that's why they are using some load factors. So that is part of the ultimate strength. So the concept of the demand is precisely part of the ultimate strength. So that they made use of the factors. Actually, ito na yung pinapakita ko sa inyo kanina. Sa NSCP ngayon, ang load combination is different from this na, no? Kasi yun yung old specifications. Pero dito, ang load combination natin is a different thing. Okay? Yan. Okay, so let me check the difference. Okay. But basically, the concept is there. We are using ultimate strength in a way that you have provided a factor for the dead load and for the live load. Oh, these are all load combination. So for the design of the ultimate strength of a section within a structure is part and parcel of it is calculation of the dimensions of the section, the materials, and the amount of the reinforcing that you are going to use. That is why you would notice in our previous discussion, particularly in the design for beam, I have identified or I have given you one problem concerning the design for reinforced concrete beam, wherein we determine first the moment, and then we analyze the dimension of the section, and then from there you determine how much reinforcing bar do we need to provide in the section. And you would also notice that we use strength reduction factor. So these are the strength reduction factors that you have noted in our example. So for beam, which is subjected to bending, which is subjected to flexure, you would encounter the value of 0.9. So 0.9 is for bending strength reduction factor. Now, if you are going to take a look at the strength reduction factor for structures which are subjected to shears and torsion, that's 0.75. And for column, for axial compression, that's 0.65. So in the ultimate strength design method, there have been some inequality. So with the demand, it should be less than or equal to the supply, meaning or the requirement should be less than or equal to the actual strength. So let's say, for example, you have a requirement of 100 kilonewton meter. For the actual design, it has to be more than or equal to that particular value. So the required ultimate strength should be less than or equal to the usable design strength. So that's why we are using factor of load factors and strength reduction factors. So meaning we are anticipating that the strength of the structure will be reduced or shall be variable So that's the reason why for bending we are using 0.9. So we are only utilizing 90% of the strength of the structure instead of 100%. Or the effects of the load, which should be less than or equal to the resisting capacity of the member. And so for a beam subjected to a gravity load, which is dead load and live load, then you can make use of this load combination. But at any rate, this load combination is already revised. Itong load combination natin na nasa 2.5. The one which I have shown you in the National NSCP 2015 edition, we have a different load combination na kung meron tayong dead load saka live load. But basically, the 2.6 equation, wherein the ultimate moment should be less than or equal to the nominal moment multiplied by strength reduction factor, will be followed. It's still enforced. Okay, so you have the design resisting moment, and you have the equation for the ultimate moment should be less than or equal to the resisting moment. Then take note of this in the rule for the USD. The supplied usable strength should be larger than or at least equal to the required strength. Okay, so the requirement should be less than or equal to the actual.